Good day, class. Today you're going to learn about the states of matter. There are 4 states of matter, 3 of which you are probably familiar with. We're going to learn really in depth about the solids, liquids, gases, and plasma. These will be your slotted notes that you will fill out through today's lesson, so let's get started. Our learning targets for today, we have 2. Number 1, identify the 4 states of matter based on particle arrangement and movement. That also means you might have to draw some figures and illustrate the states of matter. Also, number 2, explain the kinetic energy of solids, liquids, gases, and plasmas. Remember, kinetic energy is the energy of motion. Also know the shapes and volumes of each one of these, which we will fill out in a table. So let's get started. What is matter? Matter is anything that has mass and takes up space. Volume is a way that we measure that space that mass takes up. You should have done that in math class. Fill in your notes now. On a side note, here's your little joke for the Monday. You are living, you occupy space, you have mass, so therefore Einstein would say, you matter. The next thing I want to talk about is this big fancy theory that we abbreviate KMT. It is the kinetic molecular theory. It sounds fancy, but really the kinetic molecular theory is just an explanation of how particles in matter behave. There are 3 assumptions that you must know. Number 1, all matter is composed of small particles. We call those particles atoms. When those atoms join other atoms, we could call them molecules or even ions if they have a charge. Number 2, the next assumption. These particles are in constant random motion regardless of the state of matter. Number 3, the third assumption. These particles are colliding with each other and the walls of the container which holds them. Matter exists in 4 basic states or phases: solids, liquids, gases, and plasma. If you look at the figure on the bottom right, you will notice how we would model them or draw them to illustrate what state of matter they are. The lower you get toward solids, we have a low temperature of energy, and to the right, plasmas have a high kinetic energy. The first state of matter we're going to talk about is solids. Solid state of matter has a definite or fixed shape or volume. They have the lowest kinetic energy. Particles only vibrate but cannot move around due to being locked in place by surrounding particles. If you look at the figures at the bottom, those molecules are locked in usually a geometric shape, and they do vibrate. Even though we can't see them with the naked eye vibrating, those particles are moving, they are just vibrating. There are 2 types of solids though. There are crystalline solids. They have a very 3-dimensional arrangement of particles, which looks like this lattice to the right. It's very organized and patternly like quartz. Then there are amorphous solids, just like you learned in 7th grade with metamorphosis. Morph means to change, so amorphous solids are made of particles that do not have a special arrangement. They're usually flexible, bendable, or even meltable. If you look at the lattice structure right here, not all of those particles are arranged in a geometric shape. Some of those shapes are bigger and smaller. If you look at these pictures, can you identify the picture that would be a crystalline solid? If you picked Stonehenge, those are solid, geometrically shaped. If you look at the other ones, the soccer ball and the shoe, they are flexible, rubber, and they would be amorphous solids. What about the skin of that Triceratops? Would you think it would be amorphous or crystalline? If you chose amorphous, you are correct because it is flexible. It's not in a geometric pattern. The next state of matter, liquids. They have an indefinite shape. The prefix "in" means not, so there is not a definite shape or definite volume. That means liquids take the shape of their container. If it's a round bowl, it would have a round shape. If it's a square container, it'd be square, etc. They have medium kinetic energy, so the particles do move faster than a solid, but they don't vibrate, they slide past each other. So they're still in contact, they're still close together, but they're only sliding past each other. Please focus on that word. If you look at these examples, you will see various liquids, and liquids can evaporate, they can flow, they can melt, they can boil. Some more characteristics of liquids. Liquids have what we call surface tension. Surface tension is a force that acts on the particles at the surface of a liquid. If you look at the top picture, a lot of insects, because of their light mass and the way their legs are shaped, there's enough surface tension where those bugs can actually walk on water. So high surface tension, water forms spherical drops. If you look at this leaf right here, those spherical drops are from high surface tension. If there's low surface tension, like if gasoline forms or spills, it will form a big flat drop that spreads out. Another term you're going to need to know about liquids is viscosity. Say viscosity now. Viscosity is a liquid's resistance to flow. If you look at the honey or the motor oil, if you try to pour motor oil out, it pours slower than water. If you've ever tried to get honey out of a container, it's very viscous, it's very thick, and therefore it doesn't flow very easily like water. So the more viscous a material is, like a liquid, the slower it flows, because there is a stronger attraction between the molecules of a liquid, the more viscous they are. The next state of matter we're going to talk about is gases. Gases have an indefinite shape, just like liquids, which means they take the shape of the container. They'll spread out. However, gases, the particles are not in contact with each other. They have a higher kinetic energy. They're moving faster. They're flying around in the room that we're in right now, and the particles separate from each other, and they can collide and bounce off each other off the sides of the walls, and this can create currents and wind and stuff like that. Also, gases, can be compressed in these containers, in which we could have oxygen, helium, or stuff for like an acetylene torch. So gases are compressible. You can put a lot of gas in a small container if you force it in there. That's compressibility. Helium is a lightweight gas and has unique properties. You should know from photosynthesis and cellular respiration that humans take in oxygen, which is a gas, and we breathe out carbon dioxide. There's also carbon dioxide bubbles in the soda right here. You should be taking your notes and pausing periodically through this video. The next state of matter is plasmas. Plasmas are pretty cool. They are gas-like. They also have an indefinite shape and volume, but they have higher kinetic energy than gases. So plasmas have the highest kinetic energy because they are ionized. That means the gas particles are charged. And when they're charged, that means electrons are kind of everywhere and protons, and that means plasmas can conduct electricity. If you remember in class, I held up a fluorescent light bulb to that plasma ball. And as I held it close, those plasmas that were in that fluorescent bulb started to excite, and the light bulb lit up without being plugged into an actual electric outlet or circuit. So that is a great example. Also neon signs, if you've ever seen an open sign, those have plasmas in there that light up. The sun, stars, lightning bolts, neon fluorescent light, aurora borealis uses plasmas. Aurora borealis is like the northern lights. And then there are some TVs that use plasma. In your drawing though, if you look to the bottom right, you will notice there are gas-like particles here, but you'll see the charges, the positive and the negative, meaning that these are moving around way faster and more kinetic energy. Here are some of the places I just mentioned where you would find plasmas. You could see them in flames, lightning, the northern lights, sun is an example of a star in a plasma state. If you want to, you can pull up this PowerPoint. I'm not going to play it now, and you can watch this video about the 4 states of matter. But please know this slide right here summarizes in detail solids, liquids, gases, and plasmas that as you move up, energy, kinetic energy is increasing. Tomorrow, you will need this chart to help fill in your diagram for your work period tomorrow. So let's talk about the work that you are supposed to do today. Once you're finished with your notes and you have filled out both sides of your slotted notes, I need you to go to today's lesson, and there is a quiz that you will play right here during the work period. I will need to see your score and record it. I would like for you to get at least an 85 or higher. When you are done with that, make sure you have finished your vocabulary on the Quizlet vocab. Your closing today, I will do in class would be to fill out this table to see what you know for tomorrow's lesson when we talk about phase changes. You also need to have that quiz done. It will be a daily grade. You may begin.